Hi guys, here for this video I'm going to be talking about the whole concept of vertical, horizontal, compression, and stretch. We have 5 graphs here and they're all variations of the cubic function. Let's see, to start off with, the one in the middle, the red is y equals x to the third. Okay, so that's your parent function. Next to it is y equals 1/4 x to the third. Right above it is y equals 4 x to the third. Okay, the other two, it's a different color. Here we have y equals 1/4 x to the third. The purple is y equals, open parentheses, 4x to the third. Okay, so let's go ahead and decipher this. First of all, the ones in blue, the numbers in blue, this 1/4 and 4, they're called something called a values. Okay, they're a values. So a values are outside of the function and they multiply the entire function. So it could be anything like y equals, even for a parabola, 2 x, sorry, I shouldn't put a parentheses there. Something like 2x squared, something like that. Anything that's outside of the function. Now, in green, the b values are values that are inside of the function, that are part of the function, that just multiply the x. So in a parabola, it's something like, open parentheses, 2 squared. I hope you understand the difference between those two, because there is a big difference. The 2, the a value 2, this square, this x squared, the square is not affecting it at all. You're going to take whatever number x is and you're going to square it first, and then you multiply the entire thing by 2. That's why when I say it's multiplying the entire function. Now the green, the b value, notice that first you are going to multiply whatever x is by the b value, and then you're going to square the entire thing. So that square, this square outside, this exponent affects the b value. Okay, that's the big difference. Okay, now that we've identified what a values and b values are, let's go ahead and technically, vocabulary, what it means. So a values, let's pick in that color that I can see. So a values, I'm going to put down here. A values, they indicate either a vertical, stretch, or a vertical compression. Now stretching means it's being made wider. Okay, stretching. Something's becoming longer. Compression is something's becoming shorter. Okay, and then let's go ahead and do the b value. B value is a horizontal stretch or compression. Okay, so let's take a look first at the a values. Let's go ahead and take a look at the a values. So here once again, the numbers in blue are a value. So we have a 1/4 and a 4. first of all, let's go move past the a values. We notice that we have a 1/4 here and a 1/4 here. This one is an a value and this is a b value. If either a or b value, if that is between 0 and 1, just like 1/4 is, then we know it's going to be closer to the x-axis. Here's the x-axis right here, and it's closer to it than the parent function. Okay, it's getting closer to it. It's going that way to the my Surface, the fan kicks in, and that's why it gets so loud, and I hate that because you really can't hear me. But anyways, now let's take a look at the b values. Here we have a 4, and we have or not b values, but a or b values that are greater the absolute value. I'm not talking about negatives here, okay? So if a or b values, the absolute values of those are greater than 1, like you saw over here, that's a b value, and here we have an a value, those both are 4. That's greater than 1. So we notice that it gets closer to the y-axis. So here's the y-axis. Here's the parent function once again. You notice both of these graphs, this one and this one, they're getting closer to the y-axis. Okay? So they get closer to the y-axis. Okay? Now, we understood that much. Now we have to actually put a name for them. Okay, so let's go ahead and first talk about a values. So we're talking about vertical stretch or vertical compression. Now we're going to have our fishing rod and pretend like there is a guy down here holding on to that fishing rod. Okay, and as you can see, that's a vertical. That's a up and down vertical fishing rod. And I caught this fisherman has caught that parent function. Okay, and if I bring it closer to this a value here, and I make it this function, this blue function from here to here, that is called a vertical compression. That is called a vertical compression. Because what happens to the rod when you bring it, when that parent function becomes closer to him, is that the fishing rod compresses, it becomes shorter, and so that's why it's called a vertical compression. Okay, now once again, the same guy with the parent function, he lets it go, he lets unwind, and it becomes this a value, 4. So now the fishing pole has gotten longer, so this orange function with the a value of 4 is going to be called a vertical, stretch. Because what happens to the fishing rod? In order for it to go from, that's a really big fishing rod. Oh, whoops. That's a really, in order for it to go from here, this is making a mess of this picture, for it to get longer, okay, to here, well, that's called a vertical stretch. Okay? Now, I am not liking that at all. I'm going to erase this. Oh no, it's erasing the whole function. No, I don't want to. Go back, go back, go back, go back. There we go. Okay. Now, let's talk about b values now. Let's talk about b values. So let's go ahead and catch our function this way. Let's go ahead and catch our function. Let's go ahead and catch our function this way right here. There's a guy out here. He's going fishing for that function, that parent function, which is the red one, which is the red. and he's going to bring that function closer to him, to where the 4 is, to where the 4 is. Well, when he brings that function closer, when he winds that fishing pole in closer to him in this direction, and it now becomes this purple line, okay, that's called a horizontal compression. So this line right here with this 4, that is a horizontal compression. Okay, now let's say he takes that fishing rod once again and he lengthens it. He makes it go all the way to here, all the way out to here. Takes it out all the way to here. What happens to that fishing rod? That function is now transformed, or it's stretched, okay, all the way out to here. Okay, so this green one is called a horizontal, green function is called a horizontal stretch. Okay, now recap. Whoops, it's also taken away my, okay, but anyways, recap. So a value is outside of the function. For example, y equals 1/2 x cubed, and y equals, oh, I'm sorry, 2x cubed. Okay, b values are inside of the function. So we have a y equals 1/2 x cubed, and we have a y equals, let's see, 2x cubed. Now, if you just want to memorize it without thinking about the fishing poles, because the fishing poles confuse you too much, okay, then let's just memorize it. So 1/2, this 1/2 tells us that it's going to be a function that is going to, if we have it here and here, I have to graph it, guys. Okay, it's going to be this one right here. Okay, and that's the parent function. That middle one is the first one that I drew, was the parent function. That right there is a vertical compression. That involves an a value between 0 and 1. Now, this 2 is a vertical stretch. It's a vertical stretch, and it's an a value, or the absolute value of a. Absolute value of a is greater than 1. Okay, now let's talk about b values. B values, we have a 1/2 here. Okay, so that is called a horizontal stretch. So that would be a b value between 0 and 1. Now this 2 here, that is a horizontal compression. And that's the absolute value of b, is greater than 1. If you want to just memorize it, okay, then you could just memorize it that way. Okay, but I would highly suggest that you look at the graph. Wow, that was like a 15-minute video right there. But anyways, I hope that helps. Bye, guys.